Adamson were the associates architects for this project, and as well as being involved in some of the original feasibility studies, we produced the working drawings where the architects record, and we're also doing the contract administration. Michael gave a very good idea of the way in which the building was conceived, and I hope that this portion of the presentation will give an idea of how some of these ideas were implemented and built. Being green has really permeated the culture of this project since its conception. And during construction, being green really is more of a monitoring effort. And the LEED's model and framework gave us a tool for monitoring the way that materials were purchased, the way that they were built, and the way that the subcontractors signed them up. As far as key construction dates, these are some of the key construction dates. And what you see here, the most visually dominant feature of this building, which is green, is actually the base of the building. And I think that reusing this building and preserving the existing building and its foundations actually represented a material saving of approximately 3,300 tons of material and contributed to the LEED points that we achieved. And reusing the existing building also represented one of the greatest challenges that we faced. And at times it was more like weaving than it really was construction. And this slide here really highlights the way that this building was sequenced. And the entire perimeter of the building was left in place. And in order to leave it in place, one bay of structural steel was left around the perimeter. And the entire interior of the building was demolished, and it was also taken down another story to create another basement. And then steel columns, additional steel columns were threaded through the concrete along the perimeter and around the perimeter of the building to provide extra reinforcement for wind loads. And once the steel was braced, basically this was demoed, construction began, and building of the core could commence. And the demolition structure was almost like it was at a big first, and it was taken away by a LEED certified waste removal contractor. In this slide here, you can basically see that the steel at this point is just above the 10-story mark. And what's interesting about this slide is that once the steel actually proceeds to this point, then the steel tubes that frame the skylight could be put in place. And with that reinforcement, that structural load going back to the core, the slabs that were left in place behind the landmark facade could be demolished, and those would be transferred down. Another little interesting story is these columns here, which we refer to as the mega diagonals, are 90-foot columns, which weigh almost 56 tons apiece. And putting these in was actually quite a heroic effort. And these loads, which come down from the tower, are transferred to a giant horizontal truss to the third floor, which is one of the unsung heroes of the job. What this slide shows here is what we refer to as one of the nodes. And the nodes occurred every 4 floors. And I think it's worth saying that the complexity of the structural geometry and the non-vertical columns were, to say lightly, not immediately embraced by the construction culture in New York. There was a significant amount of resistance. It was before my time on the job, but I heard that people, sort of, they didn't really know what to say about it.
It's still one of the interesting things is all the fabrication of steel was done in an hour outside of Syracuse in Governor, New York. And so a lot of people were employed in that town for this project. And they were just totally fascinated how this project was completely different from any other project that they had done, and how they had to put the pieces together, and how was this going to work. And I think all with the exception of one, every piece came together. I think that's correct. I asked Frankie earlier, I think, to do some jiggering, but it was a remarkable feat.
All of these nodes were prefabricated off-site, and the building literally became an erector set. And the steel progress progressed remarkably quickly and remarkably accurately, and the steel was, where it should be. The steel in itself represented about 90% of the steel was recycled content. this slide, which is in April, the steel went up incredibly quickly. But I think what this slide demonstrates is really how efficient this structure was. And what's really amazing about this structure is that it allows every load has basically 6 load paths. So it's incredibly efficient. And it's interesting because one of the first studies that I did when I came on the job was to look and see whether or not we could save any space as we went up the tower. It's usually an exercise that's done somewhere in the job, and to see if you can get a little bit of space back. And amazingly, the column size changed only 1.5 inches from the bottom of the tower to the top, which was really amazing. Because in a tower this size, you'd expect those columns to reduce the size by almost half. So and it demonstrates it's very lacy, it's very light. And prefabrication, like the nodes, also was done when it came to some of these V panels. Like one of those V panels in the curtain wall is right here. This was the first one that was loaded on the truck, and there was a huge crowd of people there to see it. It was quite and the thing came a little bit too far. The whole truck took off the ground. A few feet, we held our breath, but that was the only time it ever happened. Because of their complexity, making these things in the shop really seemed like the right thing to do, because that's really the only place where you could make that exact. And they were lifted in place. There were about 12 movements to get it into place, and when they dropped in, they went incredibly well. Next slide. In this slide, the steel and the curtain wall are complete. At this point, probably we're saying something about the glass. We had incredibly efficient glass, floor to ceiling glass panels with low E coatings, which reflect the solar transmission as well as emissivity. So the visible transmittance was about 60 to 70%. Shading coefficient was 0.37. A few of the other green features that we employed were that the roof pavers, 75% of all the pavers had ceramic coating on them so that they could actually reflect the solar light and give off the heat, so that it would reduce the heat island effect of the tower. And also, and I'm not sure if this has really been done anywhere else in the city either, but the concrete and the sidewalk pavers also had a high albedo content to reduce heat island. In this slide, you can see the facade, and this was the first portion of the scaffolding, which was removed after the facade was restored. The facade is clad in cast stone panels, which are mounted on a brick substrate. And the restoration it's very interesting, because the restoration is you have to make a decision: do you restore a building or do you stabilize it? And they're two very different things. Restoration makes it look like new. Stabilization really stops it from deteriorating. And we did a little bit of both. We pinned the stones that we thought that were in place, so that they wouldn't sag anymore. And it was in remarkably good condition as it was. And the stones that had cracked or deteriorated, we actually replaced them. But probably the most interesting about the facade was that the best thing that you can do for an existing building is just leave it alone. So a second buffer wall was built behind the landmark wall. That space, the airspace, allowed the wall to exist in the same environment which existed for 75 years. It was basically been an uninsulated wall, and it remains an uninsulated wall. We basically added an inch of fire spray to provide a nominal amount of fireproofing and a vapor barrier on the back of that. And then it got coated with a kind mineral coating, which is in effect represents almost like a vortex kind of jacket. It allows moisture to leave the wall, but it doesn't allow moisture to get in. The coating is a translucent coating, which is a potassium silicate, which is a relatively inert product, but it allows, as a translucent material, it allowed the scars of the building to come through. And that was something that Foster really focused on. They wanted a building which had lived and showed its scars and didn't look like it was right out of Disneyland. This shows some of the landmark facade before it was restored, and you can see some urns and sculptures and some of the mortar that began to deteriorate, some of back of the wall to provide a light, a nominal amount of insulation, the new cabinet wall being constructed, this furring of status board. Next slide. This shows some before and after shots of the lobby. And as a very significant portion of the being green and conforming with the LEED guidelines means being very careful about the materials that you select and the materials that you use. And we used synthetic gypsum throughout the project. We used FSC certified woods, which are woods that are selected from forest to forest that are certified by a body. Fly ash was recycled in the concrete. The steel, by its very nature, is recycled. Local manufacturers, and as Brian mentioned earlier, construction waste was diverted. Next. And similarly, the materials for the inside, the interiors of the project also conform quite strictly with the LEED guidelines. And I think everybody knows when you pull the plastic off that chair and it smells, well, that's exactly the kind of thing that people are worried about. And there are processes and procedures in place that allow those